Welcome back to another Observable Lightning Talk. In fact, it's the September editions 2024. First of all, thank you to be connected to this live stream. Usually the Observable Lightning Talks is happening every 3 months or so. We couldn't increase the cadence, of course, if you're interested. But I think from my perspective, 3 months is enough, to be honest. So if you have never heard about the Observable Lightning Talks, so my name is Henrik Rexed. I am the host of the Is It Observable YouTube channel, and it's a live stream. Of course, the content will be available after the live stream in YouTube. So if you want to watch it later on, you have the options to connect to my YouTube channel and watch the full live stream at your own pace. If you're connected, it's probably you're connected from LinkedIn, Twitter, not Twitter, X, but X. In fact, I think it's not like a stream from X, but from Twitch and from YouTube. Which means you can interact with us during this live stream by just dropping a comment in the live stream of your platform. So then you can ask your questions, and we'll have a dedicated session at the end section where we will answer to all of your questions. So for those who never heard about the Observable Lightning Talks, let me explain the flow. Very simple. Today I have 3 amazing speakers, and I will share the names of those speakers in a few minutes. And each speaker would have about 15 minutes to present a topic. We won't ask any questions to respect the duration of this live stream. And that's why at the end we have a panel discussion where I will ask my questions, because usually I have a lot of questions. And if you also have some questions, it's going to be the right moment to drop your questions and interact with the various speakers of today. If you pay attention to today's edition, it's going to be very specific to a couple of topics that I love. So first is going to be open telemetry. Open telemetry is an amazing project. I love it. It's going to be about profiling, and I'm very excited to have a great speaker on that side, on the profiling side, and of course security. And you'll see that I have a good friends that has come up with an amazing project, and I think you should be aware of that project because it's so amazing. So you should be aware of it. So let's cover the agenda. So tonight, or today, or whatever from you're connected, we will have again 3 speakers. Constanze. Constanze, if you never heard about her, she is really impressive. For those who never heard, she has a doctorate at the Albert Einstein Institute in relativist radiation and hydrodynamics. So for me, when I first initially heard about it, I said, "Whoa, that sounds very complicated." But yes, it's complicated to be sure. And she's invested. She's having a lecture at the TOV in University in Vienna, and she do hands-on cloud-native stuff. And she come up with last year on an amazing project called the Kubernetes Storm Centre, and she will present it to us. So stay tuned. In a few minutes, she will talk about this project, which I think you should be aware, because it's going to be, we need your help, and I think it's an amazing project. Then the second speaker will be Frederic Branczyk. So if you never heard about Frederic, first of all, it means that you don't follow the Prometheus and Thanos project, because I use one of the projects from Prometheus quite on a daily basis, called the Prometheus Operator, and he was one of the initiating this project. So he really thank you, Frederic, for that, because I think everyone is using it heavily. And if you followed properly, Frederic is really up into profiling world, and he started a company called Polar Signal. So he will teach us about profiling. So I think if you never heard about profiling and how you can take advantage of profiling, this talk is going to be amazing. And last, we have Jamie Danielson. She is a software engineer at Honeycomb, and she is really involved in the open telemetry community. So she is a contributor in multiple open telemetry projects. She is a maintainer on the JavaScript project, and she's going to talk about open telemetry instrumentation. So again, if you are interested in how you should instrument your applications with OpenTelemetry, this talk is going to be great. All right, so I think you have all the agenda. So like I said, take your note. We will look at your questions, and we will answer it at the end during the panel discussions. So take a coffee, take a glass of water, take a notebook, so then you can drop your questions as well. And let's start with the first speaker of tonight's editions. It's going to be Constanze. Hi, Constance. How are you?
I'm really, really good. It was a wonderful hot day, maybe the last one of summer here in Vienna. How are you?
I'm really good. So I guess you're Vienna. So you're connected from Vienna today. So I'm connected from south of France, and we still have. I mean, it's less hot than a couple of days ago, but still, we still have the summer experience in south of France still. So I don't know if Vienna is still the same thing, but at least summer was great on our end. So I have already presented a couple of things about Kubernetes Storm Centre, and we did an interview a few months or few weeks back at KCD Munich. I watched the talk that you delivered with your 3 students. It was just an amazing talks. It's a great job, by the way, for all the 3 students. And I think your project is just amazing. So I just let you present it during 50 minutes, and then we touch base later. So I leave the stage to you, and see you in a couple of minutes.
Well, again, and also the praise for the students. This is just great feedback, and also having them. They are also part behind me, or like supporting also this talk. So there's quite a bit of input from them as well. So this is active research that is ongoing. Yeah. So is it observable? So what do we want to observe? We want to observe threats, and in fact, from the point of view of the defenders. So I've probably spent now around 8 years in being a defender on the cloud native side. So we're going to talk a lot about Kubernetes. And in the end, I'm going to basically pose the question, is there a system, or can we actually let real attackers be our pen testers and sort of turn that game around? So that would be sort of my ultimate goal. So yeah, I teach and I do research at the TU Wien, and I'm also a principal investigator for this cloud native threat intelligence project. And I think it's important to understand where this comes from. And my position was always, I was getting increasingly fed up with this idea that we have, on any given system, and here you see Neuvector on one of my actual clusters with like 2,219 vulnerabilities. Yeah. Anywhere where you are, you scan your system, and if you're not totally on top of it, you've got vulnerabilities, you've got misconfigurations, you've got alerts, and then there are vendors that try to, sell your stuff a lot because of playing on your fears mostly. And then there are regulations like NIS2 where I have my problems with, because they can be quite endangering for actually the economy of small scale businesses. And this is where I was like, I'm dissatisfied with this from a defender's point of view. I want to have a scalable means to defend against cloud native threats without running into burnout, and also sustainably in the way that we can actually learn as we go along, as we solve these vulnerabilities, and not just like endlessly fighting this hamster wheel. And this is why the vision that we're trying to build here is like, cloud native software without that fear pressure. Like, if I make to take this from Kamala Harris, like bring joy back into it. And so the idea that we built is a framework, or we're trying to build, is a framework where we have a process that we can trust in, and that will actually get us a continuous improvement over time, and where we can measure our own dog food if we're actually getting better. And we don't have to trust certain vendors and believe in throwing tools at it, but building a practice over time to really increase our threat-informed defense. So what's the process? So I think everybody here in Cloud Native knows automation really well. So what we do is we take our production system, can be a cluster, can be many clusters, can be cluster and databases, as much as you want. You decide your scope. You clone it. So basically you make a copy of it. Please take anything sensitive out of it, and then you add this honey cluster instrumentation to it. So in our case, we use Tetragon to extract kernel events, and then we have a log forwarding, log processing, filtering, all of that sort of stuff built in there. We're currently rewriting that because it got a bit bloated during our POCs. Anyway, so once you have that, you basically simulate an attack on yourself. You calibrate your signal. So you have an idea probably what you think you're afraid of. So you put those on your clusters, and then you see, okay, I'm going to decide this is a benign signal versus then I can capture whatever is the anomaly, what is not something that I expected to see on my cluster. So I can actually inject a malicious pod or use some of the attack suites that are out there and check if I can see the thing that I thought I was afraid of. So I'll play this game until I'm happy with my calibration. And then if that's my kind of risk appetite, then I can actually open this to the wild and say, well, dear attackers, let's see what you find in our systems. Are you going to actually attack us as we thought we were being attacked? And this is then the part where we can compare what we actually see versus what we thought we modeled and really learn over time. And so the setup needs to be standardized in order to be any way comparable, and also so that we can talk the same language. What we took here is an ancient format. It's called sticks, and we map onto it. This is mostly regex and stuff. And yep.
Yeah, we just see your main slide, the entrance slide. I don't know if you have changed slides, but
Really?
Yeah, we were seeing the first slide for the moment. So
the whole time? Oh dear.
For the whole time. So I was wondering if you and I heard that you clicked, and I said, okay, it means that there's a display has changed. So just to let you know, now we see the slide, so that's perfect.
Do you see it moving?
Yeah, I see it moving now.
Oh, okay. Right. Anyway, so we cloned our system, and now we said, okay, we have a modeled attack that we thought we were afraid of. And the first thing that we do in this Storm Centre is we make these detailed attack path visible. And this is something that you see now on the left. This is a multi-node modeled attack. It's a really bad one, actually uses remote code execution, a cron top, a reverse shell, all sorts of things, and data exfiltration. And what we did here is we tested it, so basically executed it ourselves and checked that we can actually see it. And what you see on the left side is that replay of that actual self-attack until we were happy that we could get the right information out of it. And so this was the first proof of concept we did with the Storm Centre, is that we can, and I don't think anybody else can, do the signals in this sort of detailed granularity, that we can see and map them in a standard fashion, that we can also share them with the world. There is no sensitive data anymore in that video. So we can basically share this with the world. Now I've changed slide. So what you need in order to see this is you need these.
We don't see that.
I'm going to do it like this.
Oh, here. Now we see it.
Okay. So in order to do these measurements, you actually need to input the models first. And this takes quite a bit of time. So why I'm going to, in the end of the talk, going to give you an idea of how we accelerate all of this with AI nowadays. So basically, for all the attacks that you're afraid of, you need to do a little bit of a model of what you think is going to happen and how you would detect it. So these are classical indicators of compromise modeled into these trees. And the idea here is that you, as any user, so this is completely open source, you know your models best, right? You know what you're afraid of, so you can calibrate this to your own observables. And I'm also going to show you in a second how you can use pretty much any LLM to make this entire thing, which is instrumented mostly in JSON. So, and you have to deal with a lot of volumes of logs, of how you can help yourselves with using LLMs to pre-generate and pre-analyze the data for you. The point of this whole game is that you have these two phases: the calibration, where you really get to understand your own exploitability. Because as before, you had only CVEs, like a list of CVEs, and often they mean nothing, really. And here you can really see, okay, how actually does the attack work? And often by design and simply by awareness, you can fix a lot of them. And the other one, which is really cool, is that once you have it ongoing in the wild, you see if your assumptions were correct in the first place. All right. So this, what I just showed you, was an attack that is, let's say, kind of classical, kind of textbook. You had lots of steps. But what about attacks that are actually extremely dangerous, but where you only have one shot? And an example is here when you steal tokens while they're valid. What you see here is that maybe I'm using managed identity, which usually has a bearer token that has a validity of about 1 hour. And let's say I also have a slightly insecure configuration somewhere in my cloud, maybe a little bit of overprivileges and a little bit of a vulnerability. It doesn't have to be a critical one. And somebody can steal that token. And what you will see here is that if you go to the repo, I'm giving you a shell script basically in this case. So if I steal this token, I can use it during the validity period and go to this SQL database here that is also in the same tenant in Google, and basically silently, so without that being detectable, steal all this data. So this is traditionally very, very hard to see, because the time that you get the audit log here that somebody has stolen your SQL data, well, that's too late, right? So, and the challenge that we're solving at the moment is, how can I get a really good quality detection on that stealing of the token before it gets used? And just because of time, so what this format allows us, especially in combination with LLMs that format this nicely to us, so we basically feed it those many logs that we've extracted from eBPF and our applications in our network, and we say, okay, we have a suspicious incident here. This is a single indicator that says it's suspicious, and what we can then do is, for example, we can correlate these different suspicious indicators over, for example, a time window, and say, well, if there are 3 of them that are suspicious, for example, the request and the response and the token being refreshed by the API at the same time, well, that's something that should ring your pager, that should really wake somebody up at this moment. We should really watch what's happening next. Now, all the things that I showed and also the things that I didn't show are actually relatively effortful to do. And while there's a huge learning effect to it, we paired up with an AI and are currently investigating on how much we can optimize our workload and also the speed of which we can develop both the attacks and the log analysis. And so currently we're using different Gemini models and seeing how we would adapt them to give us help in the following problems. One is simply analyze these literally gigabytes of logs that most of the time are completely boring. And when we then have confirmed suspicious logs, to give us the patterns for the next IOCs for the next indicators of compromise that we want to filter out in the future, especially in the exact context of our system, right? Because this is something that we want to give to users, because nobody can give all of these. There are lots of UUIDs involved. We cannot give this to a user so that it's ready to use. We can only give them the method and the framework so that they can use it themselves. And the idea is, of course, to take a lot of the toil out of it. And so I'm giving you an example now of how this can work. For example, we can input these so-called observables. That is simply your eBPF, your logs, your application logs, your network logs, transformed into that format. And then we basically ask the LLM to say, does this contain attack? Does this contain an attack? And yes, describe it, please, and tell me what it is and if I should worry about it. Here is such an attack. It looks extremely boring. It's like a TCP send message thing. Sorry, this is not an attack. This is one log. And here it basically tells us, well, this could be a potential server-side request forgery. We think it's 90% confidence. The severity is relatively high. It tells us what exactly happened here. Somebody actually accessed this metadata API. And this, so what we're calculating at the moment, what is the factor of making our lives faster and our development more efficient when we use the AI here, but it's already gotten, I would say, out of the, without proof at the moment, it's at least a factor of 10 that everything's gotten easier with this help. And that is our vision, and that's where I want to also conclude, is, so making threats observable on your specific system, given that you have the knowledge as a defender of how you built your apps, of how exactly you also know what is normal for your apps, how they should access other services, what is expected. That's something no vendor can take away from you, and that if we use it in a cyclical process, in a continuous improvement process, gives us the ability to teach ourselves as well as the let's say AI assistants to instrument our clusters in a way that we can not simply, no, but we can at least make it observable, what the threats really are and which ones we should prioritize on solving, on remediating, and of course comparing it with our own self-made attack suites versus what the attackers out there are really doing. So yeah, thank you so much at the moment. What we're looking for at the moment mostly is people that help us test this entire stack. It actually contains quite a few components, and contributions also on the threat and attack libraries. And otherwise, I can just say it's been a massive journey since we started it at KubeCon North America. And thanks so much to students, the TOV in Control.io, and also Isovalent, and you, Henrik, to let me present the topic here.
Thank you for your presentation. So I'm leaving the QR code here if you want to have access to the Kubernetes Storm Centre to have more details. I think it's an amazing project. I have a few questions, by the way, but I will leave them for the panel discussion. But I think it's an amazing project, and it deserves to be known and have more contribution for sure. So thanks, Constance, and see you in a few minutes for the panel discussion. Hi, Frederic. How are you?
I'm good. How are you?
I'm very good. Very good. So where are you connected from?
I'm in Berlin, Germany.
Berlin, Germany. So how is the weather? Because I didn't know. I don't know if you had also a lot of storm or rain, or is it?
It's been surprisingly hot, actually. Only this week it finally cooled off a little bit. Like this weekend, we still had like 36 degrees.
Okay. So it's almost hot. the same temperature that we have here. But yeah, something the temperature dropped heavily since it rained a few days ago. So, like I said, Frederic is have been doing a lot of great things on the observability world, and you are. I think we met the first time in KubeCon Valencia, I think, if I remember well.
Yeah.
And you were in the process of building Portal Signal, I remember, and then now it's here. So we're very excited on how has been achieved, everything that has been achieved so far. And also, I know you are also a part of the hotel profiling in SIG. So it's a hot topic, and some really eager to learn more. And so you can share your words and your recommendation to the community. So I'll leave you on stage for 50 minutes. And good luck, and have a nice presentation.
Thank you. All right. So today I want to talk a little bit about profiling, and especially because it's something that's not super well known, I want to start kind of from scratch to pick everyone up from zero, so that everybody can get a feeling and a first taste of what it could be like to have profiling as part of your developer toolbox. Before I actually dive into profiling, I actually want to tell a very short story of why this is even relevant at all, why we would do this. So to do that, I'm going to take us on a very short journey through computing history. So we're going to go back to 1971, which was a pretty significant milestone, especially for personal compute, because this is when Intel released the famous 4004 chip. And like I said, this was the first kind of commercially produced and kind of available to consumers chip. Now we fast forward 3 years later, and Intel releases the infamous 8080 chip. And something that was really interesting about this short period of time of 3 years was that the number of transistors in these two chips more than doubled during this time. And we fast forward to 1978, Intel releases another chip, and we may already see where this is going. we went yet another massive step in number of transistors in these chips. And you may already understand where I was going with this. This is something that one of the Intel founders, Gordon Moore, coined as Moore's Law, where initially he said that the number of transistors was going to double every year. He later revised this to every second year. And as a matter of fact, as I was talking to a bunch of folks that kind of worked at Intel throughout the years, actually at some point it kind of converted from a prediction into a goal for new chips being produced. And so it was essentially how Intel was measuring itself and how the chips industry was measuring whether it was being successful. The thing is, though, and we're kind of seeing this here already, we are kind of getting to a point where we are starting to hit the physical limits of what is possible. Because, and this is some data from last year, actually, Apple in yesterday's keynote actually made another interesting, very, very short statement, which is one, Apple is actually already today using 3 nanometer technology. Now, this is a little bit of a marketing term. It doesn't actually mean that the transistors are 3 nanometers. But the fact is that the transistors are getting smaller and smaller, and we're actually approaching the point where a single transistor is a single silicon atom. And so how much time do we have left until we're actually at that point? We saw that curve where we're getting more and more transistors on the same space, and a single silicon atom is 0.2 nanometers. So as an industry, we do have kind of a problem that we are coming to that point where physically we're not very far away anymore from what we believe is physically possible with silicon. And so we kind of are facing a reality where the hardware is not going to be getting any faster anymore, at least the hardware that we've been producing so far. However, I'm going to make a prediction that it is actually not going to change, but it's going to change it's not going to end, but it's going to continue in a different way. And there are actually 2 ways that I believe this is going to happen. And one is specialized hardware. And we're already seeing this in the AI world now. There are specific chips being produced, especially just for single purpose use, right? For inference, for example. There's a really cool company called Grok that produces a chip that is specifically used for doing llama inference, for example. And the other way that I think we can continue to make our systems faster is by actually utilizing our hardware better. And I'm not a hardware person, so the way I felt like I was going to be able to have an impact was using the hardware that we have better. And how can we do that? Well, now we've kind of arrived at the core of this talk. It is through profiling. What is profiling? Profiling is as old as software engineering, because essentially what profiling allows us to do is down to the line number understand where resources are being spent. CPU, memory, but really any kind of resources that our processes may be consuming. Profiling is there to tell us down to the line number, down to the function where these resources are being consumed. And so, like I said, that can be memory, that can be complexity. It can also be wall clock time. For example, if we want to understand how much network latency are we spending, and so on. And so there are roughly 2 categories of profiling. One is tracing, where we're truly looking at every single thing that happens and recording that, and then we can look at that at extremely, or not just high resolution, but at true resolution. This is not to be confused with distributed tracing. This is within a single process context at extremely high resolution, absolutely everything that happens in that process. This is extremely high cost. So this is something that we typically don't do in production and only in very controlled environments. There is, however, another very popular method that can safely be used in production, and that is sampling. And so essentially what this means is we look at what is the current function call stack, let's say 100 times per second over a 10-second period of time. And that then allows us to build statistics about how our process operates. This can be done at extremely low overhead in production, less than 1% in CPU overhead, and less than 100 megabyte per node where we're profiling absolutely everything that is on that host. So again, what is a sample? A sample here, because we're talking about sampling profiling, it's essentially just what was the current function call stack. So what functions were calling other functions, and then at what timestamp did we observe this function call stack? And using that, we can build these statistics. So essentially, this is maybe what it may look like. Every time we see this flashing, we are doing a sample collection, okay? So every time, and all these boxes are just functions, function names calling other functions. And so this is essentially the raw data of profiling. We just have many stack collections over time. But how do we actually visualize this, and how can we actually make use of this data so that we can fight the end of Moore's law as we know it? So probably the most famous and most popular visualization for profiling data are flame graphs, or as actually the creator of flame graphs, Brendan Gregg, also calls them when they're built from the bottom, from top down, icicle graphs. So these essentially, we're looking at this data one more time. Icicle graphs are when the root, so the first function that we're calling in our process is at the very top. A flame graph would be when it's at the very bottom. So essentially just flipped upside down here. Now, these are just individual samples. How do we make these samples? How do we aggregate them in a way that is useful to us? Well, essentially, this is what happens. We sort them so that all the same functions at the same level align, and then we merge them all into single blocks. So now we can then take this data and see, okay, these blue functions, they're actually taking 50% of all of our CPU time. So this is a subset of our software that is actually going to be really interesting to look at, because it takes up a majority of the CPU time. In this case, I'm going to talk about CPU time, but it could be any resource. But let's just take the example of CPU time. 50% of all the CPU time is spent in this particular function. So that's why, if we want to have the biggest impact, we're going to look at the functions that also use the most resources. So this is essentially what that would then look like. We merge it and then present it to a user in a UI. So essentially, the way we're looking at it is the x-axis is the amount of CPU time spent by a span, and the depth means nothing other than this is the depth of the function call stack. And again, because this is a really popular name for it, but this is a flame graph and this is an icicle graph. So if these are the same thing, we're looking at the same data, but the root here is at the top with an icicle graph, and here with a flame graph, the root is at the bottom. So performance engineering is not magic. It's not really all that complicated. We just need to measure and to see where we need to look. So I'll do a super quick demo of an open source project called Parka, P-A-R-C-A. There's a demo instance at demo.parka.dev that you can play around with. And this open source project consists of essentially two components: an agent that is powered using eBPF. It performs the stack unwinding. So it figures out what were the functions that were calling other functions at particular points in time, collects that, and then sends that to the Parka server where we can query and analyze it. So that's the component that I'm going to be showing you here. So we're viewing some profiling data, and I'm just going to refresh this. So now we can see, I'm looking at a single pod in a Kubernetes cluster, and this is a little bit meta, because it's the Parka demo itself. So there's a whole lot of stuff running in here other than Parka itself. So here we can see, a really significant amount of time in the Parka server is spent resolving symbols. So if we go somewhere down here, maybe if we group by address, we can see if we hover over these, we can see the address being 0x3a73164. This is the raw data when the BPF program performs the stack unwinding to understand what was the function call stack at some point in time. That is the raw data that we're sending to the server. And so the server needs to also figure out, what does this memory address actually mean to a human? What function name should I be showing to a human so that the human can understand it? So we can see, a good 67% of all of the CPU time of this particular Parka server is spent in this symbolization process. So if, let's say, we look at this and say, I would love that the Parka server uses less resources so that my cloud bill is lower, or that I can use the remaining resources for something else, then this is what I would be looking at optimizing, because optimizing this code path would actually have the biggest impact on our resource spend. In the interest of time, I'm not going to dive into all the other visualizations that are possible with profiling data and that are available in the Parka project. So I encourage everyone to check out demo.parka.dev so you can play around with it yourself. We also have a Discord server that you can join and ask any questions that you might have. But yeah, I'm going to jump back to my slides here and just say, I think now you have all the tools available to deal with the end of Moore's Law. So long live Moore's Law.
Awesome. Thanks. I'm a big fan of Brendan Gregg, so I love the fact that you make a reference to him. So thanks for that. And I had some questions, but I will leave it to the end, to the panel discussion. So thanks, Frederic, for the talk. And let's move on to the next last talk of tonight, which is Jamie's talk. Hi, Jamie. How are you?
Doing well. How are you?
I'm good. So where are you connected? I didn't ask you. Where are you?
I'm in the United States. I'm in New Jersey.
New Jersey. Okay, cool. So where in New Jersey is it? Because it's kind of a long state. Where precisely?
Yeah, it's pretty long. I'm kind of near the northern part of the state, maybe 45 minutes outside of New York City. So most people know about where that is. So kind of around that area.
Okay, so I see there pretty much a lot of companies based there out there as well.
Yes, and in a lot of suburbs as well. Lots of trees and houses. Yeah.
Cool. So I know that you're. So how long have you been contributing back to OpenTelemetry? So because you've been doing a lot of work in the project. So how did that start?
Sure. Yeah. So I had started working at Honeycomb about just over 3 years ago. And in joining in Honeycomb, the first thing that I was working on was open telemetry and getting involved there. So it's been probably about 3 years since I started working on open telemetry.
Okay, cool. So, I will leave the stage to you. So, yeah, let us share the secrets of instrumentation. There's a longer version of a talk, or another version of this talk that you did at Hotel Day Seattle, I think. So, if you want to see that talk, you can search on YouTube. You can find it. But here it's a shorter version. So, stay tuned and good luck, and see you in 50 minutes.
Cool. Thank you. This talk is called Fine-Tuning Automatic Instrumentation. As Henrik said, I did a version of this at OTEL Community Day. I've changed it up a little bit here, so hopefully there's still a little bit of new stuff that you can learn, even if you've seen the other talk. Again, I am Jamie Danielson. I'm a software engineer at Honeycomb, and I am currently a maintainer on the OpenTelemetry JavaScript project. So you might see me around on OpenTelemetry a bit here and there, and hopefully you won't get too bugged by some of the examples primarily being JavaScript, but that's a bit of my happy place. Most of these will exist in all of the different languages. So we have a pretty straightforward agenda. We're going to look at what is automatic instrumentation. We're going to look at some of the configuration options you have available for you with those instrumentations. And we're also going to look at some options we have available if we add a collector into the mix. So we start with what is automatic instrumentation. Now, this is a bit of a controversial term that you'll see. I like to point out this issue that exists in one of the repos. I can't remember quite where, but the thing is, it's complicated. Automatic is kind of a loaded term. There's a lot involved. Generally, the way I want to look at it is we have automatic instrumentation is sort of anything that generates instrumentation for you. This is the way we're going to look at it, as opposed to maybe custom or manual instrumentation, which is where you're going to be adding a lot more into your code at that point. Hopefully I don't confuse you too much with this, but this is sort of the way that we're going to look at it, sort of a high level explanation. What you may see, for example, is going to be on the OpenTelemetry docs is we have a bit of an explanation about this, as well as a full section on zero code instrumentation. So the idea of zero code is really that you are not touching your code at all. You have some configuration available for you, usually via environment variables when you're setting them up. And most of the, most used languages at least will honor environment variables for a lot of that setup. And for those that don't have all the environment variable options, or maybe there's sort of a limited amount available, we have this other thing called low code. And what that means is you're going to be adding a little bit more configuration in your code. It may only have to be a single file when you're initializing an SDK or registering instrumentation, but you're going to probably have a little bit more control and flexibility in those times that you get to do that. So if we want to dive into it, we're going to look at what some common instrumentation configurations are available. What a lot of people are unsure about is, they've heard automatic versus custom instrumentation. And for some, it can be a little bit intimidating going into custom instrumentation. They want to start with automatic. In fact, this is a very common place to start. It helps you get, some visibility into your application. But what you may start finding is you're maybe getting more than you expected, or you're getting some things that aren't as useful for you when you're looking at the telemetry that comes out of that. So we're only going to look at a few examples here, but there are a ton more available. The link that's up on the screen right now should bring you to, I believe it brings you to maybe the Java page, which probably has the most robust setup for your different configuration options, especially with environment variables and things like that. The Java agent is incredibly flexible and customizable. But what we're going to look at are enabling and disabling libraries, maybe disabling spans based on specific criteria that you might have, and also capturing your HTTP request and response headers as attributes so that you can then see that in your telemetry backend. So when we look at enabling or disabling specific libraries, this is primarily going to come into play when you're using what's called a meta package. So a lot of the languages have this meta package, which means just that it includes a bunch of instrumentation libraries in one package. So instead of needing to find everything that you might possibly need, it's sort of an easy bunch of things that you can add to your project. Typically, what you'll want to do when you're first starting out, especially, is you'll want to add this meta package and then get a feel for what's generated from there and just disable the ones that you realize you don't need. Later on, once you've figured out exactly which libraries you do want to keep, then you can go to just enabling those specific ones and ignoring everything else. So how do you know what you want to disable when you've added in this meta package? So as an example, we're going to look at JavaScript. This is an example of a trace on the left side that shows this post request with a bunch of lines for this file system instrumentation. Now, I cut this off actually for how long this trace was because I wanted you to be able to see it on the slide. But on the right, I also added a screenshot of just how many spans or events are included in, this grouping of traces that I have, not just this one, but several over a period of time. I'm most interested in those HTTP requests and those spans from Express, which is what I'm using in my application. File system might have some interesting things, but oftentimes we're going to have a lot up front that we don't actually need as it goes through, each file in my system. So what I might decide is maybe I don't need this, or at least I don't need this right now. So this is an indication that I want to disable this one and see if I find some value or some changes I want to make later. As an example of this, I'm showing this in code for JavaScript. This is also available in an environment variable, but for the sake of kind of showing this, where environment variables may be more straightforward, this is simply getting the get node auto instrumentations, which is that meta package I talked about, and specifically disabling that file system instrumentation. This may be a way that I continue to customize these or disable other ones that I decide that I don't want to have. Another scenario that you might want to disable certain spans is if you have things in there that, again, you find are not super useful for you. Maybe you have health checks or admin endpoints or static assets. There are things you're finding in those distributed traces and those waterfalls that aren't adding enough value for you for what you're looking at. Some common ones, like I said, you have your health check, maybe. Or maybe you have a /admin or a /test or /dev URL that's just for internal purposes and isn't going to help you figure out your production system. Or you may want to ignore based on a specific name or layer type. Layer type, by that I mean maybe you don't need your middleware spans or something to that effect. So this is just kind of a simple example, again, in JavaScript, where we might say in our HTTP instrumentation, maybe I don't want those spans that are coming from static assets. That could be something as simple as, a favicon or something else. I put that right here in this setup of my instrumentation when I realize that I'm seeing that in my telemetry backend and it's not providing value to me. Another common scenario is when you may want to have headers added as attributes on an individual span. So your HTTP headers get sent along with your requests, and there are some standard headers you'll notice are already going to be on your spans as part of the HTTP semantic conventions. So for example, you're going to see a user agent as an attribute already on your spans. But there may be other headers that you have added in your own application that you find is useful and something that you want to be able to see in your telemetry backend, because we're not going to have all of our headers added, but there may be some useful ones that we want. An example of that may be something like, I don't know, if you have a specific synthetic ID or you have a team ID or X custom header, something like that. that would be how, you would want to add that as an attribute to your span to get more visibility into it. So here again is another example where we have this headers to span attributes, and we're saying that on our client request headers, we want to have this X forwarded for header added in there. So there we talked about we talked about quite a small amount actually of instrumentation options that you might have available to you with your application. There are a ton more. Again, in the interest of time, I wanted to keep this to a very short but commonly requested list. There's going to be more on those links that were added earlier. But now I want to give this other option here that's available. So ideally, you make as many changes as you can, as close to your application as you can. That helps reduce, the amount of processing or exporting that has to happen. But there are going to be times where you aren't able to do it there, or you want to have maybe a double check at the end. So after you've already you've generated and exported your telemetry from your application, you've made those configuration changes that you did, you find other things that you want to change. So for those who don't know what a collector is, this is sort of a very brief diagram of what it might look like. And essentially, it's your application. Instead of just sending directly to your telemetry backend, you send it to a collector. And that collector then sends it to one or any number of backends. And what that collector can do is it can transform your telemetry in different ways by using different processors that are available. And I'm just going to talk about a couple of common things that people may do once they've gotten this telemetry to the collector and they have a few last minute changes before they send it along. So one of the common things, this is one small thing to do with the transform processor, which is actually incredibly versatile, is going to keep having more examples added to of things you can do. But one thing you may want to do is duplicate attributes or add in attributes that you don't already have on current spans. So some folks might know that HTTP semantic conventions were declared stable. I have a screenshot here of the blog post that went out. And very basically what that means is some of the most commonly used semantic conventions for HTTP instrumentation have had this change over time. So for example, http.method is now http.request.method. And there's a few of those that are like that. And what has had to happen is instrumentations of different languages have to implement these new conventions, but also have an environment variable available for you to maybe use both or pick one or the other. Depending on where you're at in, your instrumentation journey, what language you're using, what versions you're using, you may not have the option available right there in that instrumentation to make those changes. So you can come to the point of a collector where this is cut off a little bit. You'll see this online though, but the idea here where we're saying, okay, I want to transform my spans and I want to set this attribute of http.request.method based on the http.method attribute. The idea here is I don't want to have one or the other. I want to have both so that all of my instrumentation is able to kind of have the same fields available. So I'm not trying to analyze between one or the other. It's just easier to make sense of that. Another thing that may come up is that there are some instrumentations like gRPC that add a lot of span events. And again, it's important to first see what that telemetry looks like and decide what's important and what isn't for you. But in the times that you do have a lot of span events, and if you're having to say pay for them with your backend, it can be useful to have an option to drop them if they're not useful. So again, this is just a kind of basic example of using this thing called a filter processor that then says, if there's any attributes that are gRPC and they match this, then I want to filter them out of my trace. And finally, it has become somewhat common to drop information at the collector using the redaction processor. So you never really want to have any PII or sensitive information in your telemetry in any of your attributes or anything else, but you may want to have a backup just in case it had been missed at the start, or things happened and this is just necessary to ensure that you're not sending along sensitive information. So when something like that happens, you can use this redaction processor, and what this is saying, allow all keys, means drop everything. Take everything off of my spans and only allow in these certain keys. I don't know what's in there that may be dangerous or sensitive or whatever else, but I know that these few keys are good enough to get the value that I need without possibly exposing any sensitive information. So a lot of these are going to have more examples also on the GitHub repo, but these are just a couple of common options that you may think that you need to have. So as a recap of what we just talked about, I threw a lot of information at you in a short period of time. But the thing to keep in mind is that if you're using those automatic instrumentation libraries, there are probably more configuration options than you realize. There's more knobs that you can turn to tune that instrumentation to get more value out of what telemetry is getting sent to your backend. And in the times where you need to do just a little bit more beyond what you've done at the instrumentation level, you can also add in this open telemetry collector to help with some post-processing and other transforming of your data to get it into the shape that you need to be able to analyze that later.
Awesome. That is, and in fact, there is a couple of attendees who ask questions about your session, so we will cover them in a few seconds. So thanks, Jamie, for the presentation, and let's jump into the Q&A. So see you in a few seconds for the last section of this Observable Lightning Talk, which is the open panel discussion. See you. All right. First of all, good job, because I think nobody exceeded 15 minutes. I think great job. And Constance had this stressful startup where part of the sharing was working or not working. It reminds me of what happened at KCD Austria, where you had a similar. It was even worse, to be honest. This experience. So I guess you've been trained to that kind of weird situations.
Well, I uploaded the PDF to your Slack yesterday, right? Because I was like, "There's something's going to be there," and like, I'm going to give you the slides this time because that's what I didn't do at KCD. Anyway.
But you have it, so I will try to share it somewhere on the post for.
Nah, computers. They're the worst. I don't know why we work with them sometimes.
So let's. So I have questions for Constance. I don't know if Jamie and Frederic has, but I will start with my own questions first. So first of all, when I was at the KCD Munich, the demo was so well prepared. So the student did an amazing job for that, and you explained the entire process. But one thing that I was wondering, say, okay, now we are modeling an existing threat attacks that we know, and then we try to replicate it, and then feed the systems to then create those patterns and detect and help to get the right alerting. So having one person chasing for all the potential attacks or threat is quite impossible. So how can we improve it to have continuously new threats added in the system, simulates those threats? Because also I think it's kind of a significant work to simulate this attack as well in an automated fashion. So what is the process behind that?
So this is a really, really good question, because I don't, at least in the open source frameworks, I didn't find a single one that does actually do a lot of interesting attacks in one of these loading frameworks. So our current ongoing research, and this is probably the biggest question, is can we use sort of geometrically trained LLMs to do the combinatoric pattern, where we're basically, so we know, at least in Kubernetes, we know each individual attack type. So, and then you can read them on, a lot of like, for example, Google Cloud documentation. There are these individual indicators unknown. What can happen? For example, sensitive mount or something. So now combining them and then asking an agent to like test this step, and if it finds that it works, go to the next step. So this is something that we want to long-term implement. For now, we do it sort of piecewise. We ask, again, the AI do help us. So basically give us a type of an attack for this step and then generalize it. And I do it personally in bash scripts and just, basically chain them together, try them out, and construct these trees. But my goal would be to have a fully, if you see these trees, have a full set of all possible trees in Kubernetes. And I think it's possible because Kubernetes, it's not exotic anymore. The only thing that is exotic is, for example, the exact SSRF type. Because depending on how you write your code, especially if we look at front-end code, there's 15,000 gazillion ways of doing that. So that will be specific always. But the rest, what happens on the Kubernetes side and also even on the cloud side, how you abuse an OAuth or a JWT, a JSON Web Token, that's pretty vanilla by now. So I think it could be done. But it's difficult, and I don't think anybody has done it yet.
Yeah, and also what I liked with the visualization that you briefly showed us on your slides is to be able to go from the beginning to the end. So showing where the attack took place and where the attack is heading to, because at the end, there are common agents that will say, "Hey, there's a suspicious event. Here, there's suspicious events," but linking them together and saying, "Oh, he is trying to do this." And I think that is quite super helpful for everyone, for sure. But yeah, so how can companies or the community contribute to include more and more attack patterns or have more rules into Kubernetes Storm Centre? Because I think here it needs to have if everyone is collaborating to this, then we can basically have a dictionary, or not a dictionary, like an inventory of all the potential attacks that could happen in a community's world. And I think that will be great to have it. So how can people contribute there back?
So currently, I think, so we have a couple of things. One is what also Jamie mentioned is it's important to filter out very early. And it's very difficult to say in a generic context, where am I going to put us an asterisk in, I never want to see this, or I always want to see that type of thing. So having better rules there also, or maybe different examples that people can start with, because at the moment you do get a bit lost in the beginning if you just set it up the way it's, you have to exclude quite a few things in the beginning when you, because otherwise you'll drown in the logs. And the other one is the eBPF tracing policies. They were quite good, but a couple of attack types are missing. We're not covering, for example, buffer overflow types. We couldn't see them at the moment. So if there's somebody in the eBPF world, typically you need kernel knowledge to do this well, really targeting, okay, this type of attack here, I have a nice tracing policy in eBPF so that people have a starting point to go from there. That is cool. And also the attack classes at the moment simply. So for example, for this token stealing, I'm putting Terraform there for Google and Azure, and also some sample pods that have sample vulnerabilities. So you can do your calibration yourself and start this sort of learning journey with having a starter. And these starters can be contributed by anyone who has a nice semi-realistic vulnerability that can be abstracted away and contributed.
Okay, cool. So Frederic, maybe I was wondering if profiling could be also a way of detecting, I don't know, spawn processes in the middle of the code. I don't know if that makes sense, because I think you mentioned sampling. So I don't know if profiling could be a tooling that could add weird processes in the middle of a stack code. I don't know if that makes sense or not.
So I think it's less about detecting new things, but I think what's really interesting is there are a lot of tools out there that will tell you, your dependency has this CVE, right? But very, very often you don't exercise that code path or something like that, right? And then it just ends up being noise. Something that we have thought about is with profiling data, we can for sure say, if we have profiling data that exercise that code path, you definitely should be fixing this CVE, right? Maybe we can even say someone has been trying to like specifically penetrate this particular vulnerability because that code path has actually been exercised a lot recently. So for those purposes, I think profiling data could be really interesting. Now, because of what you said regarding sampling, we cannot prove the absence of it, but in the presence of it, we can definitely say you should.
Yeah, but it needs to be because potentially the attack is happening here once during a few seconds, and then it needs to be detected. The sample needs to be happen during that time frame, which is kind of very short window, to be honest.
Yeah.
But it can help, if I may say, because you also use eBPF, right, to do basically the systrace or strace something, and to find the right hook points. Because currently, what we have to do is we have to basically profile the application and check what would we hook in the kernel to see the vulnerability, and that's basically what you already have in a different context.
Yeah, it works a little bit differently. So we actually attach to perf events. So you can think of it as on a CPU overflow basis. So every X amount of CPU cycles, our BPF program gets called, and whatever happens to be on the CPU at the time is what we do the stack unwinding for. So that's how our BPF program gets triggered.
Okay.
And to Constance's point with the buffer, the missing stuff on the buffer, from your knowledge on eBPF, would that be easy to add to detect those type of events?
Are you asking me? Or are you asking Frederic?
For Frederic.
I don't know if I can confidently answer that. I think our the funny thing about eBPF is it's almost like serverless, right? Like one thing using eBPF is totally unlike the other thing using eBPF, and we just happen to use some technology that has the same name, but what we do with it is totally different. So
different, yeah, for sure.
I don't know that I can answer that.
Okay, no worries. So Frederic, maybe do you have any questions to Constance about the Kubernetes Storm Centre?
I guess so long time ago, I was doing security research where we were doing actually really simple analysis with trigrams of syscalls that were following each other. I'm just curious, because I did this 15 years ago. Is this something that's still actively done? Is this way in the past?
Well, so the logs that we look at are essentially just inheritance calls of different processes, right? And then you see that this process has been corrupted, or this process is suddenly called with a different argument that we haven't seen before. So that's the same thing. I'm not sure if I can answer your question because I'm not sure if I understood it.
So basically, back then, what we did was we analyzed, environments where we're this environment has not been tampered with, right? And we were recording trigrams of syscall sequences, right? And if in the wild we observed a trigram that was not in the set of good syscall sequences, basically, someone may be alerted and has to potentially look at it. Do you think this is still something that's being done? Do you think this is with new LLMs we have way more context that we can include in this?
So I think this is actually how the virus detection and the malware detection works. So we don't use that level of detail at the moment because I think we would DOS ourselves if we went for this call. We have to be very selective in which kprops we attach to because, yeah, it's just simply the mass of data, especially with network packets when they so but theoretically, if you know which one you're looking for that is somewhat significant, then we would do that as well. But we basically go for heuristics at the moment. and a lot of manual experimentation, to be honest, because we cannot afford to do a full syscall analysis, a full fingerprint, basically. But I think the idea totally exists. Absolutely, yeah.
Awesome.
Jamie, do you have any questions to Constance?
Yeah. So I was kind of curious about, so you mentioned that you have, I think, like your own test suites that you run against this. Is that something like you kind of like as something new is found or a new vulnerability is exposed, you can then add that specific scenario into your test suite, or how does that work?
Yeah, pretty much. So currently the way we started was asking pen testers or red teamers, like, what do you typically test for? Like, where do you start? And like put that into a script first. So and then we took what we could find in the other open source test suites that, big names here, all of them that are classified in like MITRE. And yeah, and currently it's just like whatever I find that is significantly different from what we already have, I try to have at least one sort of poster child to add. Yeah. And it's not necessarily new CVEs, even though the leaky vessel one, yeah, that one I did a demo with because it was so awesome to just go for root directly. Yeah.
And small, did you have reach out to CNCF fuzzing, because they do a lot of validation for CNCF project, doing some pen testing and so on. So have you reached out to the team that do those tests to contribute back to Kubernetes Storm Centre?
Not yet, because as far as I know, it's more on the application side itself, if I'm correct.
It is. Yeah.
They try to fuzz the application, whereas we were more on the, behind. We assume application compromise happens somehow. We often build a fake vulnerability into it, and then we check, can we see that the rest of the thing, because that's what no one else has so far done. You know what I mean?
Yeah.
So,
yeah, I know completely.
But maybe I'll talk to them in Salt Lake. Yeah, it's a good idea. Thank you.
You're welcome. There's a small comment from Rock Darko, so I'm going to display it because we made a small comment about using tracing and eDPF to and then with the sampling. So thanks, Rock, to make that comment. I think it makes sense, but I think the sampling is definitely a point that. But if the attacker is doing it quite often, then probably we could combine and detect things. So Frederic, first of all, amazing. I love the talk. Usually I like history, so I like going back in this story. And for me, the Moore law is difficult to follow, I think, but I think it was a good point to use that law to bring profiling into the picture. I never have the chance to use Parka, which reminds me that I need to do an episode on that to play around with it. And I use Pyroscope and I use Pixies. And what I really liked, I mean, Pyroscope at that time, before they've been acquired, they were able to have with a specific profile agents that they were using to be able to link a profile to a given hotel trace. And I thought that was, when I was using it, I said, wow, this is exactly what I need, what I want. So my question would be, have you thought about doing this? I know that with eBPF, it's kind of tricky because you don't see potentially the trace the moment where you're building the your profiling. So is this something you're working on, or you have thought about it?
Yeah, great question. So actually, there are two ways that we kind of went beyond the simple distributed tracing integration. So one, yes, we can actually do this from eBPF, which is really cool. So basically, what we do is, and it depends a little bit on each language, but let's take Go as an example. Go, the runtime manages something called thread local store for each individual thread, and Go routines that are scheduled onto threads by the Go runtime can have labels, and this is actually the same mechanism that Pyroscope used to attach just a distributed tracing ID. We actually expanded this so that you can attach any label that you want to the profiling data. So you could also add the customer ID or a username or whatever might be useful to you to understand and break down the profiling data further with additional information. And so we can do anything, and distributed tracing ID could be just one of those labels. And then with eBPF, what's really cool is that we can basically understand how the Go runtime stores these labels on the Go routines, and we can actually read it from the process memory just fine. And so we can do it with zero instrumentation as well, and I think that's really cool. And actually, tiny hint for viewers, we're actually just about to launch the same thing for just about every other language. Which I think has not been done so far. So, yeah.
So it's another argument to force me doing an episode on Parka. Okay, I understand.
Let's do it.
And another thing is Pixie had so Pixie is also based on eBPF. They do profiling and other stuff on a cluster, and they had this notion of I don't remember the name of Pixie query language. Pixie language. I don't remember the name, the exact of the name, where you were able to create Pixie scripts and extract from the Pixie storage and build whatever you wanted. And they had this plugin that they built initially for New Relic, and you can easily use it for other purposes because it's OpenTelemetry, 100% OpenTelemetry. So they were able to get from trace, from a profiling perspective, to generate an OpenTelemetry trace. And I thought, it kind of interesting to get somehow not every seconds, but having a huge sample, but get an idea on what's happened on the kernel, on the procedure level, or more on the code level, to get that details. Because sometimes, to Jamie's point, instrumentation is great, but sometimes you want to have details. But again, the question is that really tracing, or is it profiling? So do I really need the trace to get the profiling data? But I thought that feature was quite interesting. So also, do you consider to have a feature where you can export like a trace here and there, I don't know, every an hour or so, to get the distributed trace from a Parka perspective? Have you thought about that?
Yeah, so we've played around with it, but honestly, we haven't found using like a distributed tracing viewer for profiling data to be particularly useful. I think it was created for distributed tracing, and I think that what it shines at. And distributed tracing has its place still, right? With profiling, even with profiling. So I think these integrations of being able to jump from distributed tracing data to profiling data, or vice versa, I think this is the really powerful workflow. And I think something that's really, really cool about our system, because everything is zero instrumentation, right? You don't need a library, you don't need an SDK, nothing. The agent does everything automatically using eBPF, right? So the really cool thing is, if you have distributed tracing instrumentation, we'll pick it up from every process that happens to consume CPU resources. And what that means is, all of a sudden you'll be able to see flame graphs for an entire request, right? Not just a single process, but throughout your entire infrastructure, because that's the mode of operation for our agent, right? You deploy it on every node in your infrastructure, and therefore will also pick up all the CPU time that was used to process this entire request, whether it was in one process or hops through multiple processes. Right? So I think that's really, really cool. To your point about PixieScript, so PixieScript was primarily concerned with everything that wasn't profiling, right? So I think what PixieScript was really cool for was adding new log lines dynamically to your application, where without you having to redeploy your code to add a new log line or metrics. And so I think that's what such a language really shines at. So I think I don't anticipate us creating something like that for profiling, but I do think this is super valuable for those kinds of more static kind of instrumentation, right? Like metrics or logging. Because profiling is really about, you want to see the true function names of your code.
Yeah, and optimize them. Yeah, by directly. Yeah. Constance or Jamie, do you have any questions to Frederic?
I guess I was just thinking about like kind of like we talked about like that combination of things and having both profiling and distributing tracing. They each have their own space, and I love that. And I was just thinking of the Open Telemetry Go instrumentation, the automatic instrumentation that's out there now. I think had been originally donated and now worked on, and that uses eBPF to do that distributed tracing. And so I guess I'm curious, like, have you had maybe an opportunity to use both, like use profiling and that Go instrumentation? And how did that go?
So we instrument all of our Go code directly with distributed tracing, instrumentation. So we haven't really had a need for the eBPF based instrumentation, but I certainly think this is really cool that we're seeing more and more zero instrumentation, because at the end of the day, it's exactly like your talk, right? If we can get it to be less effort to use these tools, people can have wins much faster, and that's just better for everyone.
And it will increase the adoptions for sure as well.
Definitely.
Yeah.
Constance, do you have any questions to Frederic?
Yeah, I was wondering if you see the usage more in the development side, where, I mean, I did HPC way back when, using Valgrind and using all the let's say very detailed profiling back then to making things really, multi-threadable and blah, blah. And do you see it more on the development side, or do you see it in production, the usage or the most, benefit for the user?
Yeah, so we definitely see people using it in production the most, because nothing, like with any other observability, nothing behaves quite like production, right? And so often it's also really hard to build a benchmark that's actually representative of your true production workload, right? And so having profiling data from production at extremely low overhead, opens people's eyes. Like, we've worked with database companies that are, notorious for being extremely performance conscious, and even they saw a 35% improvement like hours after deploying this for the first time, right? So it just goes to show that, like, if you don't have the right data, there's nothing you can do, right? It's kind of a classic data problem, or really like any other observability.
Yeah.
So thanks, Frederic. So Jamie, the last talk of today's observable lightning talks. I really like the structure. I know that everyone is starting with automating instrumentation, and then they look at the trace. They say, okay, it sounds kind of good. And then when you have a production issue, say, oh, okay, I think I have too much details. So based on what you recommended on how you can filter, you can customize, what will be the process? Do you suggest to have a QA process where you validate the actual trace produced and then tweak slowly the auto instrumentation? So because at the end, we have the techniques to filter out, but then the question is, how and when should we do it? And how much effort should I spend doing this? Because then I think it's a continuous effort. But I would like to get your feedback on that.
Yeah. So I'm a huge fan of doing this as you're developing, as you're writing the code. So whether that goes to a paid vendor backend, or even a lot of this you can do with a local open source project. You can use Jaeger or Zipkin or something. But what I like to see then is, if I run, again, this isn't production, but if I run this application and I can see the traces that come out have these extra spans that I decide are not useful, I go make that change to my code, and then I send it again to my local environment and see, okay, is that better? Is there still something extra here? I'm able to tune this a lot locally before I even push that code up to production to get deployed. And then at that point, once it's in production, as Frederic said before, there's nothing like prod. You don't know what's actually going to happen in the wild, but if you can get some of those low-hanging fruit while you are still working locally, that's a great way to keep moving. And it helps you know, did I break anything in the meantime? Is there anything else that I've now, changed about my application that I didn't expect to? So I think that's a great time to do it, is just locally as you're writing it.
And then, for example, I use the auto instrumentation for GraphQL. So I think the level of spans produced is just insane. And I think they are very very useful when you're actually building the model, or you're looking at how the data is structured and what is the consequence of it. But then once you have done that, then you don't need that detail. So I always thought, oh, I want to have like a trace for debugging or dev, and trace for prod, and you know what I mean. So when I'm building, I probably need those details because I'm changing it, and I need that details. But once I'm in production, my SREs, they don't even need that details. It's just going to be flooded by too much details, and that won't be helping them to be more efficient. So I know that it's not part of the specs, or there's nothing about it, but it would be so cool to have that type of options. I don't know if you...
Well, I see people do it in different ways. The quickest way I can think of right now is doing this in code, but almost like feature flagging your observability, where it says if your environment is production, then use this configuration. If it's development, use this configuration. And I've seen people change feature flags, like if things are going on and they're like, I need more now. Let me go change that. And yeah.
But for the auto instrumentation, if I'm not wrong, it's been loaded once the code starts. The auto instrumentation library are loaded. So which means if I do use feature flags, it needs to you have to restart somehow the pod. So then the library would be enabled or disabled depending on the feature flag. I think that's the
That's true. Another wild idea is this is where the collector comes into play. Collector can take in things from multiple places, process them, and export to multiple places. So you could send everything to the collector and then have, a pipeline that says to your, regular backend and one that goes elsewhere. Maybe your logs go to your one backend and your traces go to another. That's something to consider if you have some interesting debug logs happening in your app as well.
Okay. There's a small questions that Rock Darko explained. So that I will first display the first piece because he dropped in 2 questions. So currently filtering actor calls from Spring Boot app to the hotel collector using filter attribute on HTTP route. If I understand here, the best practice is to do it in the code and save the processing. So that's the first question. And then he had another questions. Here it is. No. Okay, and which is it's a lot of calls every 15 seconds. What are the impact on the collector if I choose to keep filtering them for more flexibility? So doing at the code level or doing at the collector level. So what would be the most efficient way of doing it?
I think the general rule is, as always, like it depends. The benefit of things that you can do at the application level is if you're changing things that are generated, that means that less then has to go through the pipeline in your application. Less has to go through processors, less gets exported, less goes across the network, all of that. So the opportunities that you can do that early in the instrumentation part, that's usually going to be ideal, especially if the setting exists already. Now, the times where it's more useful to do it in the collector is, for example, you might have a ton of data that you can't change early enough in your application, or you're kind of, having trouble with memory. One of the benefits of a collector is you're offloading things elsewhere, so that it can maybe be beefed up a little bit with a little bit more resources, so it can handle more of that processing more than where your application is running. So it could end up being sort of a try and see how it goes. But generally, if you can do it earlier in your application before processors and exporters, then that's usually going to be a good way of doing it.
All right,
Hope that helps.
Sure, definitely. So, Frederic and Constance, do you have any questions related to Jamie's talks?
I wanted to check for the automated one. Like, if I wanted to start out, are there languages systematically that are better or worse, like whether compiled or interpreted, functional object, whatever, or just certain families of languages that work better out of the box, or is it? Yeah.
Yeah. It's hard to say that anything other than Java is number one. Java is just like when you're not sure about what to do next, whether you're working in the language or your own thing, it's kind of like, what would Java do? What has Java done already? And let me go kind of copy that. Java's done a fantastic job with the agent, very hands-off with a lot of customization. I think each of the languages have their own flavor of instrumentation. And generally, if you look at maybe the top 5-ish. This kind of changes depending on what you're looking at, but things like, Java, .NET, Python, JavaScript, and then, Go is a little bit different, and Ruby. So Go is, as Frederic said, you're usually going to do a lot more in-code changes. It's a little bit more verbose. You're very explicit about what you're doing. That's where the Go Auto Instrumentation project came out with. You don't have to touch your code, but now it's using eBPF. It's a different process in doing it. The Open Telemetry operator actually has options available for injecting auto instrumentation without having to touch it.
Nice. Thank you.
Frederic, any questions?
Yeah, so you shared a couple of like snippets of like configuration for like post processing. I will say this is probably one of those things that I struggle the most with when I configure the Open Telemetry collector. When you struggle, where do you go to figure out what to do next? Because I'll be honest, sometimes I find the documentation to be a little sparse.
Sure.
Yeah, and also making your collector, if you have an issue, the logs produced is sometimes difficult. So the process of building is kind of complicated, but it works.
Yeah. One thing I like to do a lot of is one of the export options in the collector is to a file or to the console there. And so I'll look at what literally is coming out of here right now from what I've given it to what comes out the other side. And that gives me a feel in a faster feedback loop. Usually can't do that with a huge production app because there's too much. But if you're able to do like, here's a small reproduction of here's what a span looks like, what I want it to be, send that in, see what it looks like after. That's a lot of what I'm doing with local testing it out, put collector in a Docker container and try it out there. It does have its own telemetry, like you mentioned, with like metrics and logs, but I don't think that's quite what you're looking for. You're wondering if I use a processor or something, is it still giving me what I expect at the end?
Yeah,
So
exactly.
far, that's what I have in mind. And maybe, we have some automated tests we've started doing where we export it to a JSON file and we write tests using this thing called Baxcore and JQ. Basically, we can be language agnostic. What's coming out of a collector is what we expect. But from there, you have to know what it should look like to start. Sorry.
So Flinbit Flint has a, I think it's a filtering. Yeah, it's a filtering plugin called Expect, and I thought that was so great. So when you're building your pipeline, you can build steps. You say, I do that processing, and then I expect this. So of course, when in production, doesn't make sense. But at least when you're building it, you did a transformation, you extracted some fields, and then just a step afterward, you say, oh, I expect this, by the way. And then at least you get somehow feedback from the log perspective that what you have designed in your transform process or whatever didn't work. And that will be very, it's just for the dev and testing purposes, but it doesn't really have you use it for production. But I think it would be great to have it.
You can run it in CI then. Yeah, it's like, we use them as just smoke tests. We don't get super, super granular with them, but something like, okay, do I still have these attributes that I expected to have?
Yeah.
Do I still have this instrumentation? Okay, I'm in a good spot.
Yeah, agreed. All right, I'm looking at the time, so we are one. I did two. I should have looked at the time a bit more. Sorry for that, guys. But at least it was a good conversation. So I enjoyed it. So thanks everyone. So thanks Constance for presenting the Kubernetes Storm Centre. Thanks Frederic for giving easy words and explanations around profiling. That was great. And thanks, Jamie, to reminding us the journey and how we can adjust the auto instrumentation. So thanks for everyone for taking the time, building the slides, taking the time to present. I think this live stream doesn't work without a speaker. So thanks you to be here. All right, so let's conclude briefly. We had 3 amazing sessions, and I think it's time to close the live stream. So if you enjoyed today's live stream, don't forget to like and subscribe, as usual, to the channel. And of course, this live stream will be is recorded and will be available on YouTube, and I will share some posts soon. So then you'll have the different timestamps for each talk, so you can watch each talks individually. And of course, if you have any questions once you're watching this offline, you can still drop a comment with questions, and I will try to reach out to each individual speakers to answer to your questions. So thanks a lot for your time. Thanks for spending an hour and 34 minutes, to this live stream, and see you soon, I guess, for another Observable Lightning Talks. So see you. Bye.